Hi, I'm Don McKenzie. We'll get started now. I'm an associate professor in the Transportation Engineering Group here in the Department of Civil and Environmental Engineering at the University of Washington. I'm joined by my colleague Jeff Ban, who is.
Hello.
Are you associate or full? Jeff?
Associate for now.
Still associate for now. Professor
Yeah.
of Transportation Engineering here as well in CE at the UW. And so our goal today is to tell you a little bit about our grad programs and kind of how we run them, the different program options available, the coursework, which has changed recently. That's pretty exciting. And so we'll go over all of that, and then we'll have time for any questions at the end, certainly. There we go. So, what I would say is that one of the big themes in transportation that is creating a lot of interesting challenges for us to solve as transportation engineers is the convergence of transportation with other technical systems. So whereas traditionally we could focus on building and operating the transportation system, we're seeing now the need to integrate and work across disciplines, for example, with people in electrical engineering, because when we look at things like electric cars, when and where and how we charge those cars has big implications for our mobility, so things we care about as transportation engineers, but also those put big loads on the electric grid, so that creates operational challenges if you're an electrical engineer. And similarly, we're seeing smart grid technologies emerging that are simultaneously allowing those power systems engineers to much more carefully and reliably control the electric system and bring in new sources of generation like renewable electricity. And analogously, we have ITS, intelligent transportation systems, that are now really coming into their own and allowing us to more smartly manage and operate the transportation system. And then looking to the future, we see a future of sort of electric, connected, potentially shared vehicles, automated vehicles that are really going to be drawing all these systems together. So that's really cool because it creates all these new opportunities for doing things more efficiently. It also creates a lot more challenges, and some of those challenges are technical, and some of those challenges are non-technical. We'll come back to that in a moment. But suffice to say, this is driving an evolution in transportation engineering and what it means to do and practice transportation engineering. So traditionally, transportation engineering meant designing and operating roads and streets and highways, essentially, designing, operating, maintaining. In the future, we have to think more broadly, right? Why are we doing those things? Well, really, it's about allowing people to have access to goods and services and opportunities. And that means providing mobility for people and for goods and optimizing that. So that's really how we're evolving as a field from the traditional into the future. And practically speaking, what that means is we need to bring in a lot more skills that would not be in kind of your traditional transportation engineering tool set. So a movement towards greater understanding of logistics and optimization, not just for the logistics people, but for all transportation engineers. Similarly, networks, modeling and analyzing networks and the resiliency of our system and how it interacts with other systems. These are often generating and throwing off huge amounts of data. So how do we collect and manage and extract information from that data? That's sort of the realm of data collection and management tools, as well as statistics and machine learning. So it's these new skills are becoming increasingly important. I said before, though, that not all of the challenges are technical, and a lot of the really vexing challenges are due to people, frankly. So when we're working with transportation, we have different stakeholders. We have drivers, we have transit riders, we have DOTs, we have transit system operators, we have freight carriers, we have shippers. All of these people have different interests, and this diversity of interests and from these different stakeholders means that we have many different competing goals that we need to satisfy. And when you're operating in a system where there are extremely high capital costs associated with building new infrastructure and high degree of political scrutiny, because these are often publicly funded systems, it makes it really important to get this right and to do it well and to maintain the performance of the existing system. We're talking with transportation about a system that is already built out, and now we're going back and trying to make it better. But you have to do that You can't just tear the whole system up and rebuild it. We need to do this while maintaining performance. And then additionally, the decision-making about this is distributed, right? It's distributed between the government and the private sector. It's distributed between the federal, state, county, and local governments, and even among individual agents who are making decisions about how and when and where they travel. So ultimately, it's people are this sort of this element of the system that you cannot ignore, and that actually are where a lot of the challenges come from. And that's also, again, what makes it kind of fun. So reflecting this kind of diversity of interests and diversity of skills that are needed in transportation today, it's increasingly important to have an understanding from multiple disciplines. And so our faculty in our program, we have 7 faculty in our transportation engineering group. Among us, we have a background in 8 different disciplines. So almost all of us have at least one degree from outside of civil and environmental engineering. Jeff here has degrees. You have in computer science and automotive engineering as well. Yeah. And so, you have kind of sketched out, Yinhai Wang has a computer science degree, and Goodchild's background is mathematics, Ed McCormack in geography. Linda Ing Boyle actually chairs our industrial and systems engineering department now. And I'm kind of the outlier here. The weirdo, right? I actually don't have any degrees in civil engineering. And so again, what this reflects is the idea that we are moving from just a world where transportation engineering is build and operate roads to a world where it is, provide and operate a system that moves people and goods, and recognize that that is a complex system with a great deal of political and policy oversight and engagement. And so that's kind of the evolving world that we're working in. And again, makes this interdisciplinary expertise valuable and essential, and also a really interesting place to work. And so given the breadth of topics, our degree programs are really designed to be flexible, because we recognize that every student who comes into our program probably has a little bit, at least, there's some common themes, but everyone probably has their own unique goals, and exactly what they're hoping to get out of that program is going to be a little bit different from student to student. And so we really have designed our program to be flexible to meet students' career goals. So maybe someone is really interested in transportation planning, someone else might be really interested in transit, someone else might really like highways. And so you can we have these different application areas that we've kind of illustrated on this slide vertically, but cutting across all of that are a set of skills that we have identified, and working with our alumni and stakeholders in industry, have identified as really important skills that are common regardless of what your application area of interest is. These skills listed in the horizontal bars are kind of cross-cutting skills that are really key regardless of what your particular interests are. And so we've designed our curriculum to make sure all of our students have a foundation in all of these skills. So starting this year, we have just launched a pretty major overhaul of our graduate curriculum. So we have sort of reoriented our graduate core curriculum. This applies to both our master's and our PhD students. And the idea here is we really want to make sure that everyone has this common foundation of skills that they're going to need regardless of what their area of interest is. And so the first of these courses is Planning for People and Freight. This is a transportation planning course, but it is really unique as transportation and planning courses go compared to other universities. And what sets our course apart is we are looking not just at people, but we're looking at the interactions between people and goods movements. So again, transportation is not just about getting people to places, it's about getting things to people, moving goods to people. And so the way that we are teaching this course now recognizes that there is a broader set of stakeholders, and that we need to plan and accommodate not just travelers, but goods movement on our roads and at our curbs and throughout our city. So that's a really unique twist that we put on that course. Now, the point of that course is really to make sure, that's really to kind of get everyone on the same page about, like, what are we actually trying to do? What is the purpose? What is the reason we're actually doing all these things as transportation engineers, right? It's to focus on the goals of how we're trying to make our cities and our economies run better through better transportation. The next 4 courses, 512, 513, 521, 522, are really a foundation of technical skills that we believe all our students should have. So transportation data collection includes both traditional survey methods and newer methods for web scraping and pulling data from application programming interfaces, more automated data collection. Networks and optimization, which Jeff is teaching, gives a foundation in network analysis and network modeling, as well as optimization methods. Inferential data analysis is a sort of intermediate applied statistics class that goes over many of the most common types of statistical models that are used in the transportation engineering research and practice today. And then data management and visualization teaches how to handle and store and retrieve large volumes of data and how to visualize those to extract useful insights. And through all of these, I guess what I didn't put on this slide is that we're in 3 of these courses in particular, we have specific skills that we're teaching, programming skills. So Jeff teaches Python in 513. 521 introduces the R, statistical computing environment, and 522, data management and visualization, is based around SQL. So, SQL for data storage, Python for optimization, R for statistics. We also have quite a wide variety of elective courses, but students don't have to take electives just in our department. We actually require our grad students to take at least 1 class from another department, but they can take more. And it's really, you sit down with your advisor as a grad student, you propose a program plan, and they talk, and you explain and identify how that plan is going to meet your career goals. And then, we review and determine if that makes sense. But, many of our students take quite a number of courses outside of the transportation engineering program, because it may be those courses that are better aligned with what they want to do as professionals. So I mentioned we have a number of programs here, and so we have sort of three distinct master's programs on campus, and then a couple of online master's programs. We also have a PhD program. So I'll kind of start on the left side of this diagram and work across and describe these. So the thesis-based MS program, this is sort of a traditional 2-year research-intensive master's program. Most students would take 2 years to do this. They would typically be supported as a research assistant when they are doing it. And that is, most students who do that would do that because they're planning to continue into a research-focused PhD program. The non-thesis master's program is a little more flexible. So some students have gone from that program and continued on into a PhD program. Others do this program then going out and working in the professional world. Some students can get this done in a year. Others will stretch it out over up to 2 years. So the non-thesis program, really the key there is it's flexible and it's more driven by the students' priorities and interests in terms of both timing and what their goals are after. There's also I'll come back to that, sort of the research content of those I'll come back to momentarily. Sort of the third master's program we have is sort of a variation on the non-thesis. So we have a PACTRANS master's program. PACTRANS is one of our transportation research centers on campus. They provide support for domestic students pursuing master's degrees, and I can talk more about that momentarily. But students who do that would be more likely to be, working an internship while they're doing it, and then they'd be going out to work in engineering practice after they finish their master's. And they would typically finish in about a year. And then we have 2 online programs that I won't really talk about further today, but our Master of Sustainable Transportation, which is directed by Professor Ed McCormack, and our Master of Supply Chain Transportation and Logistics program, which is directed by Professor Ann Goodchild. Those are out there. You can learn more online. I'm not going to talk more about them today. So this is what I wanted to kind of talk about, the distinctions between the thesis and the non-thesis master's program. Formally, The distinction is really that the thesis-based program has a higher emphasis on research and a lower emphasis on coursework. And you can see that reflected here. Practically speaking, you know, you mix, the students all freely mix together. They take the same courses. The required core is the same. Students take the same classes. They work together on teams. They are advised by the same faculty. So these are, the distinction is not as great as it might seem. The non-thesis students do have more flexibility, particularly in how intensively they want to pursue research. So that the 3-credit research report is sort of the research requirement. And we do expect every graduate student in our master's program to do some kind of research. But for the non-thesis students, that can be a relatively light research requirement. Or I've seen students who come up with a research paper, a non-thesis student who comes up with a research paper that really looks a lot more like a thesis. And we've seen students go out and get these published in the academic literature. So it's really up to the student and what their goals are and how well they, how they work with their advisor to shape their own research. And then again, the internship track, this is like the PAC-Trans track. Again, what you see here, this is similar to the non-thesis program, except 6 of those coursework credits can be replaced by credit for going out and working in an internship with a company or an agency. It's also possible to pursue concurrent degrees, and this can be driven by the students. But one of the advantages of being at a big school like UW is that we have a huge ecosystem of other programs here on campus. One of these that I want to mention in particular is the eScience Institute offers a data science option for PhD students right now. We have this already approved for students in our PhD program. They can take a data science option. We are pursuing approval to get this in place for our master's program right now. What that would mean is essentially that required core that we have for our transportation engineering graduate students actually fulfills most of the requirements for the data science option. The only thing students would have to take in addition would be a programming class and a seminar on data science sort of across campus. So giving a little bit of a broader perspective on what data science means. And so we think this is really, this is cool to see sort of a transcriptable option available to our students, recognizing that the program we built does give them a pretty solid foundation in data science. Other students have done a master's in statistics, have done certificates from the Evans School, or do a Master of Urban Planning, and there are others. Really, it's up to the student, and the sky's the limit just in terms of whatever other departments they want to apply to while they're here. Finally, I'll say that we have a lot of resources to support students. I mentioned already the PAC-Trans internship for domestic master's students. So this is a program run by PAC-Trans, the Pacific Northwest Transportation Consortium, which provides tuition support to students, and they are then able to go out and work a paid internship to cover living expenses, all while pursuing their master's degree. There are also research assistantships and teaching assistantships. These are typically for thesis track master's students or PhD students. We have what's called the VALA Scandinavian Scholars Program. This is a program that allows students, usually PhD students, but sometimes master's students, to visit a university in Scandinavia and pursue research over there. We've typically have 1 or 2 students a year go. It's surprisingly easy to get, given how cool a program it is. Students also do internships kind of outside of the PAC-Trans realm. They just independently pursue internships. And I guess the last thing that's worth mentioning is, through our own connections with companies and agencies, we generally have access to, a wide range of, interesting data sets that can support students' research interests. And then lastly, I think to understand kind of how research here happens, generally, what happens is that research projects are usually organized under a lab. And each of us as faculty kind of runs a lab. So Jeff runs the intelligent IUTS. How do you have a pronunciation for the acronym?
No, just IUTS.
IUTS, yeah. And mine is the Sustainable Transportation Lab. So you want to say a bit about what you do in your lab, Jeff?
Yeah, I can say a few words. We basically interested in any aspect of the urban transportation systems. I do systems like system optimization, networks, look at the connections. Could be control of the traffic lights, could be optimizing, the schedules of, services, or could be data. We try to make sense of data to learn those patterns and try to, apply that into the systems or networks. So that's the two main things I work on.
Yeah. So the others, the Human Factors and Statistical Modeling Lab, that's Linda Ng Boyle. They focus on human factors, which is generally safety focused, and it's basically looking at sort of the micro scale, sort of second to second behavior of drivers and travelers in the who are using the transportation system, but mostly with an eye to understanding how to improve safety. Yinhai Wang, I point as if you can see me pointing at the screen, sorry. The STAR Lab, that's the Smart Transportation Applications and Research Lab, that's led by Yinhai Wang. They're, I think, our largest lab, and their focus, they do a lot on sensor development, data collection, data management, machine learning, those sorts of topics. The Sustainable Transportation Lab, where I am, we focus on applied travel behavior in the context of electric vehicles and emerging transportation technologies, basically trying to understand which of these things have the potential to make transportation more sustainable, and how do we realize that potential. The Urban Freight Lab, that's Ann Goodchild. They focus really on, I think it's pretty self-explanatory, the movement of freight in our cities, not just on trucks, but on newer modes, whether it's robots, whether it's cargo bikes. A lot of it is very focused on the practical aspects, a very strong applied focus there. So things just, right down to how do you manage the curb, how do these drivers get parcels, final 50 feet up to where they need to go. So very focused on the practical aspects. And Jeff, do you want to say anything about Cynthia's Think Lab?
Think Lab, I try.
Because you've worked with them more than I have.
So it's directed by Professor Chen. I think traditionally they do a lot about transportation planning, behavior of travelers. But recently they moved to transportation like the network science, the disasters, resilience, and also the big data analytics. That's the project I'm working with them right now.
Yeah. And then finally, I thought I would close by kind of talking a little bit about some of the places that our alumni go. So this slide's actually a bit of a hodgepodge of both places that our alumni have gone and also just companies that we work with. So again, you see this breaks down into kind of the traditional agency and government contracting kind of side on the left, and then a lot of these more sort of emerging mobility type companies on the right side. And again, particularly for the ones on the right, but really across the board, that's where we're seeing, the increased need for, sort of data science skills. And so that's again why we've redesigned our curriculum is to prepare students to compete on the right side of this and to be more competitive on the left side as well. And I think that's really kind of the key idea is that, regardless of where you're going in transportation engineering, it's moving in more of a data science direction. And we want our students to be prepared to compete in that world. And again, we think but where we can add extra value is not just churning out data scientists, but data scientists who understand and care about the why. What are we trying to do as transportation engineering professionals? And that way we can do it better. You can be better than just a data scientist if you understand kind of how the transportation system works and why we're doing this. So I think I will stop there and welcome any questions. I'll say that Eric Huberty is available. He's our graduate advisor through the CEG Info email address. And if you have questions about logistics of applications, you want to send those to them. If you want to talk research
courses
and things like that, then you should absolutely feel free to reach out to faculty directly, and don't be afraid to reach out a second time if you don't get a response.
This is the end of the quarter. Sort of busy.
That's the way it goes.
And also, I would add, if you go back to the first slide. So on the right-hand side, we are, the list is growing. This is just a partial list. Like the past summer, we had the students just went to Apple and other, take off.
Yeah.
So this list is definitely not the.
It's interesting. Yeah, we've seen students go to Amazon, not just in transportation roles, but we had a student who went, and she's
just
now
programming.
Yeah, she's programming and supporting AWS. So it's pretty cool. Yeah, the breadth of opportunity that we're seeing.
And also given the location, UW.
Yeah. Anyway, we should open it up for questions, or if there's anything, Eric.
So if you have questions, there's a chat box in the bottom that you can type things into, and I'll read them aloud. I've got a couple prepped that maybe we can start with. So a question that we get a lot is, I'm interested in one of the research tracks, but I don't have a master's yet. Should you be applying directly to a PhD program? Do you think it's worth applying to a research master's? And along those lines, if you want to connect with a faculty member, what's the best way to reach out to kind of explore the potential of doing a research track?
Do you want? I can answer first.
Yeah,
you can jump in. So the opinions of different faculty may differ on this. I would say though that. So there was a couple things. So one was, should you apply directly to a PhD?
Start master's, PhD.
Yeah. So formally, we do not admit students directly to a PhD program without a master's degree. We will sometimes admit students who do not have a master's but want to do a PhD. We may admit them to a master's program with a strong expectation that they will continue to the PhD. But we recognize that there's sort of an off-ramp for either party at the end of the master's. So if someone spends 2 years on a master's degree, you may spend that time and realize that this, from your perspective, kind of sucks, and you don't want to do a PhD, and that's a good time to exit. And from the faculty member's perspective, it's also a time to really kind of see how well the match works with the student, and make sure that it's someone whose interests align with your own research and whom you are able to advise effectively. So I think particularly for PhD students, the relationship between advisor and advisee is it's an intensely collaborative one, and you really work, it's like you really put your brains together very closely for a couple of years, and so you really need to have the right kind of match on working style and expectations and way of approaching problems. So there's really a strong fit element there, and I think admitting someone to a master's first provides really a good opportunity for both parties to make sure that works. So I like the system we have of admitting students to a master's and allowing them, to then apply to a PhD. But in practice, it's often, it's kind of yours to lose.
Yeah. We do sometimes, in rare cases, we do accept students without master to PhD directly, but that's unusual situations. I have students in that category, but I agree with Don. It's a little risky to do that for both students and faculty. So
yeah. And what was the second part?
And then, so if you're interested in doing a research track, usually they want to, it's helpful to connect with faculty ahead of time. Is there a preferred way of trying to make that connection?
Yeah, email, and then email again after a couple of weeks.
Yeah.
Are there specific questions or things a student should be highlighting to really help you guys?
So as faculty, we get dozens, maybe hundreds of inquiries from interested students.
Yes.
And 90%, to make up a number, 90% of them are generic. Most of them could have been sent to anyone in my general area of work, or sometimes it's just something they've written to someone in a civil engineering department.
Right.
So I think the most important thing is be focused. So when you reach out to a faculty member, you really should be writing a different email to every faculty member that you are writing to.
That's right.
And it should be tailored and based on their research, and it should make it clear why you want to work with them specifically, and what kinds of topics and what ideas you have that you would bring to bear. And I would say that there's probably an understandable desire on the part of students to blast out and approach as many faculty as they can. But I think the dilution effect will outweigh the breadth. So you are better off having, 5 really intelligent conversations with 5 faculty than sending out some generic note to 500. So really do the legwork up front and figure out who it is you want to work with and be able to explain why and what you would bring to their lab. That's probably the most important thing from my perspective.
Yeah. You most likely get a response. Because we can see immediately if this is a blank email.
I try, and I don't get it every time. I try and respond to everyone, but some of them, you send me a generic email, you get a generic reply.
Yeah.
Great. I think that's really helpful to hear. Another thing that I was thinking about, as you brought up that everybody in the department kind of has a different background and different disciplines, it seems like transportation could draw people from a lot of different backgrounds, not traditionally CEE. So what either like coursework or skills or work experience you think is really essential for being both a competitive applicant and being successful in the program if you're coming from a non-traditional background?
So
you talking about the masters or you talking about PhDs?
I think more so on the master side. Like if you're trying to get into transportation engineering, let's say you didn't do a civil degree, maybe you come from a math background, or maybe something kind of even farther afield.
So most of our master's students come from a civil engineering background, or if they're international, they may come from a transportation engineering. And I think in China, it's more focused. So they have transportation engineering specifically, but most of our students come from that kind of background. But I don't have data on this, but I would say a non-trivial fraction come from outside.
Yes.
And I think that's one of the things that's cool about our field is that, we as faculty bring expertise from other disciplines, and we also recognize that students come in with different perspectives and different expertise.
Yep.
And a lot of what you need to be successful in transportation is, an interest, an abiding interest and commitment to the topic, to the subject matter. And if you've got that, and if you've got some modicum of quantitative ability, we teach the rest. I mean, that's kind of, that's what we're doing. And so a lot of our grad program doesn't presume that you have an undergrad degree in civil engineering. You will not be successful if you don't have some quantitative chops.
Right.
And so again, I said up front that a lot of what makes it hard is the non-technical. But if you can't do the technical and the quantitative, then you won't be successful. So you do need that. But, many people have those skills, even if they got a degree in, social sciences or humanities or urban planning or, whatever discipline. So those folks are out there. They're all over the place. We recognize that. And so we want to bring in those different perspectives. And then, we train you, to be a transportation engineer.
I think part of the curriculum reform we did is try to tailor students from different backgrounds. We try to foundation for them by taking all the required courses and then go from there. So hopefully that's
Great. And then one final question that I have, and if there are more, feel free to throw them in the chat. But in terms of kind of the after the program, obviously your students end up in a lot of different places. Are there any, what do you think are there particular advantages of maybe trying to go the internship route in terms of job placement, or do you think, it's kind of 6 one way, half dozen another in terms of where students want to end up, which of the particular master's routes is kind of better for that? Does that make sense?
I don't know that one is better or worse. It is primarily about students' interests and goals. I think something we've heard from applicants in the past is that I think they wrongly believe, they have a misperception that the non-thesis program is only for people who are going to go to practice. We've had students who've done the thesis option and have gone off to work in engineering practice.
Yeah.
We've had students who've come through the non-thesis program who've gone on to PhD programs.
I have one of those.
You have one?
Yeah, you have probably.
I don't think I have one right now, but several of mine have gone elsewhere.
Yeah.
Lost one this year.
Yeah. Well, same, if you talk about it, that's more to other schools. But I have one right now from our program as a no thesis and, join our PhD.
Yeah, I would say that if you want to go into practice, then doing an internship is an excellent idea. So that, especially if you're someone who's coming from outside the Seattle region and you think you might want to stay here, as we have a lot of migration to our region. We have a ton of transportation investment happening in our region. And for folks who want to tap into that pool of jobs, I think a good way to do that and to quickly build your network is to pursue internships while you're here. But again, being in that thesis versus non-thesis, that's not a hard sort, right? I mean, you can move back and forth between those. Well, not between the programs, but between kind of the outcomes, whether you go research or go into practice.
It's not a determining factor.
Yeah. And also regarding the internship, I think being in Seattle, I haven't seen any student who wanted to do an intern and end up cannot find an intern. So all of them can find an intern just if you just try to find it. And because of our connection with the industry and agencies, they actually reach out to us to publish those announcements and opportunities. So if you really wanted to go, after the graduation, you wanted to work in industrial agencies, the internship I think it's crucial. And especially for international students, I saw at least my advisees, 2 of them are international. They started internship after after the first summer. They continue doing that during the quarters, and they got offers. And one of them, they both actually turned the offers with better places. But you see the opportunities and the importance of the internship.
Yeah, because I think the transportation group specifically is one of our best groups at being really connected to the industry in the local area, and you see that by just the diversity of placements that students end up doing internships. Okay, is there anything else you'd like to add? Otherwise, it seems like we're kind of winding down. If you have questions, feel free to reach out to CEG Info. That's kind of the general advising email, and we're happy to answer questions or redirect as need be. But any last words?
No,
I think we're great.
Welcome you to join us.
Thanks for joining, and we look forward to chatting to you all soon.
Yeah, if you have questions, just let us know.
Thank you all.